In number 8, we are given a toothpick pattern where in diagram 1 we have 1, 2, 3 toothpicks. In diagram 2 we have 1, 2, 3, 4, 5 toothpicks. In diagram 3 we have 1, 2, 3, 4, 5, 6, 7 toothpicks. So diagram 1 has 3, diagram 2 has 5, and diagram 3 has 7. Now for A, we need to find an equation relating the diagram number and the number of toothpicks. So let's let n equal diagram number. And then let's let t equal the number of toothpicks. Okay, so for every diagram, we move up to 2 toothpicks. So like when we go from one diagram to the second one, we add 2 toothpicks each time. So which means that the t has to equal 2n. Now let's see if this equation works. In diagram 1, when we have n equals 1, because it's diagram 1, we plug in 1 here and we get 2. Do we have 2 toothpicks in diagram 1? No, we don't. We have 3. So how do you make 2 into 3? What if we add plus 1 to our equation? Now what happens? For diagram 1, when we plug in n equals 1, we get indeed 3. Now what about for diagram 2? When we plug in n equals 2, we get 2 times 2, which is 4, plus 1, which is 5. So diagram 2 also works. Now we have to try this out for all 3 diagrams. If it doesn't, that means our equation is wrong. Okay, so for diagram 3, when n equals 3, we do 2 times 3, which is 6, plus 1, which is 7. So this equation works for all 3 diagrams. And as you can tell, this is a partial variation. Okay, so for B, we need to find out how many toothpicks there are when we are in diagram 20. So that's when n equals to 20. Now we have to use this formula we got from A, and we need to plug this into our equation. So n equals 20 right here, and we get t equals to 2 times 20 plus 1. 2 times 20 is 40, and then we're adding 1 to it, so t equals to 41. And t is the number of toothpicks, so that means, therefore, in diagram 20, there are 41 toothpicks.